Good morning. Today we are going to discuss new topic, that is abrasive water jet machining. In short, it is called AWJM. Okay. So this process, actually this is a combination of abrasive jet machining, that is AJM, and water jet machining. Today we'll see this abrasive water jet machining. Okay. Also, it is also known as abrasive water jet cutting, also AWJC. Now, in this lecture, in part one, we are going to cover the starting with the introduction. In that, we are going to see the applications of abrasives. Okay, in machining. Then we are going to see the working principle of this process. Then mechanism of material removal and application. Okay, this is a part one. In the second part, we are going to cover the remaining topic. Okay, so before really we go for the working principle of AWGM process, let us see the some of the uh, particular applications of this abrasive water jet machining process. Okay, and here I am trying to show you various process which are based on totally on abrasive. Okay, or where you are using the abrasives in cutting or the machining process. So here you will get that different processes where you are using the uh, abrasives. Okay, so you can see that there are some in first table you will get that there are some traditional processes are there which are based on the applications of this abrasives. Okay, now we are somewhat familiar with the abrasives because we have learned the abrasive jet machining process. So we know that the abrasives, okay, which type of abrasives we are using for the different operations. Okay, so if you take the help of this abrasives in traditional machining process, then which are the traditional machining process? So they are grinding, honing, then lapping, then surface finishing, and similar other processes are there where we are taking the help of the abrasive. That means the these are the traditional processes which are based on the applications of the abrasives. Okay, applications of the abrasives. Now, one of the points to note over here is that all these processes are applicable for electrical conductive as well as the electrical non-conductive materials. And the what are the advanced machine processes are there no? So which are based on the applications of abrasives. Okay, that are also I have shown the here. So which are that process? So you can see the first is the abrasive jet machining. Okay, AJ. Okay, so this process AJM, which we have discussed earlier. Okay, so already we know that the working principle and the setup also, and how we are taking the help of this abrasive. Okay, so there is a carrier medium in abrasive machining, which is carrying or moving the abrasive particles. So carrier medium, we are taking the air or the inner gas. Okay, which will carry or which will move the abrasive particles. Okay, so that air which is easily available. So normally we are using air, okay, as a carrier gas. Okay, also that air is as we know that it is cheap and it is not toxic. So that is preferred over there. Okay, air as a carrier gas. And here also air that air driven abrasive jet. Okay, when it is used in the our abrasive jet machine process, that time whatever the we are getting the metal removed rate, no, so it is comparatively low. Okay, also the accuracy is not very good, and the efficiency of the that machining using the this abrasive jet machining, it is also low. Okay, that is also we study. So there are various venues of improving this abrasive jet machining process that we will discuss in the next slide also. Okay, due to the low material removal rate, due to the low accuracy, as well as less efficiency. So there is a scope or different venues of improving this process. Okay, again another side we have given the another process. Okay, where well we have the or we have that process based on the application of abrasive. That process is called ultrasonic machining. okay, USM process, okay, which is also based on the application of abrasives, okay, in cutting or machining of various advanced engineering materials, okay. As we have just gone for the overview of this ultrasonic machining, okay, in chapter number 1, and the details about this process we are going to see after this process, abrasive water jet machining. Now, in that also, uh, in ultrasonic machining process, there also carrier medium is liquid, okay, and abrasives are mixed in that liquid, okay. So normally water will be the carrier medium in the ultrasonic machining, and that water is mixed with the abrasive, okay, and after that mixing, it is normally called, or it is known as slurry, okay, abrasive slurry, and the tool in case of the this ultrasonic machining is evaporative at ultrasonic frequency, okay. The tool in case of ultrasonic machining will vibrate at ultrasonic frequency, and this process also gives the material removal uh, low, okay, comparatively low. Also, efficiency is also low. Okay, so some improvement have been made in this particular process to develop new processes, especially the processes which are used for finishing purposes. Okay, that I will show you in the next slide also. So as you can see on the left side hand, the improvement of the here you can see the here I have shown that improvement uh, of abrasive jet machining is a result, and that result is known as the abrasive water jet machining. Okay, whatever we have studied the abrasive jet machining process. Okay, its efficiency, then the accuracy and your material removal rate, it is low. So we have gone for the improvement in that process, and that improvement after development in that improvement in the jet cutting technology. So we got new process, and that new process is called abrasive water jet machining process. Okay, which has many advantages compared to especially with this abrasive jet machining process. So you can see here I have shown some advantages of this abrasive water jet machining process, and that abrasive the advantages here I have stated. So the first is that there is no dust in the environment. Okay, then whatever material removal and the abrasive particles are there, so all of them are within the water. So whatever the environmental pollution is there, so that is minimized. Okay, compared to the again abrasive jet machining, it has a very high cutting speed. Okay, it has very high cutting speed. Also, there are no thermal traces developed in machinery workpiece, because first thing is that whole workpiece is there, no, it is completely in contact with your water, okay, throughout your machining process. So there is a no thermal traces generation action. Okay, also the process are comparative in the localized area only. Okay, again there is no delamination. Okay, when you are machining the composite material or glass fiber reinforced plastic. Okay, so that has some examples: machining of composite materials, then glass reinforced. Okay, so there are no fire hazards, also low level of power requirement, and what is the quality of edge cut is there, no, so it is comparatively better. Okay, and other hand, okay, this was the development of this abrasive water jet machining. Okay, that means the improvement in your abrasive jet machining, you got the abrasive water jet machining. But another side, you can see on the another side, as an improvement over the your average that this process, ultrasonic machining process, we can say that we are having the process called abrasive flow finishing, or it is also called abrasive flow machining. Okay, I repeat once again, as an improvement over the ultrasonic machining process, we can say that we are having a process called abrasive flow machining or abrasive flow finishing AFM process, which is using viscoelastic material as a medium in which abrasive particles are added, and this viscoelastic material which will act as a self deformable stone, okay, and which will be discussed in another uh, uh, chapter we can call, or in the lecture, because this abrasive flow machining, it is not in our chapter. Okay, now in this particular what will happen, there is no ultrasonic aberration as we have seen in our ultrasonic machining, but in case of this abrasive flow machining, there is no ultrasonic aberration. Okay, but in case of here, it uses the normally hydraulic power unit for applying the force. Okay, and sometimes we can also use pneumatic power for giving the sufficient force for the movement of your piston, so that it pushes your medium inside the working zone. Okay, so that is the working principle of abrasive flow friction. Okay, so how the applications of the abrasive are there in the field of machining that we have seen. Okay, first we were using the abrasives for the that abrasive jet machining process. Okay, so it's an improvement we have gone for, and developed process is called abrasive water jet machining. And another one side we have taken the example of ultrasonic machining also, and its development means our abrasive flow mixing process. Okay, so this is the applications of abrasives in machining, okay, that we have seen. Now let us understand the working principle of abrasive water jet machining. Working principle of abrasive water jet machining. Okay, it should be or we can also call abrasive water jet cutting also. Okay, abrasive water jet cutting also. Now you can see here, okay, this is the schematic, the diagram I have shown in this slide. So this is the schematic diagram of abrasive water jet cutting system. You can see abrasive water jet cutting system, you can see. So there is a high power water tube, you can see a high pressure water tube is there, okay, through which a water at a very high speed, at a very high, high pressure is supplied. Okay, this is the once again repeat, high power water tube is there, through which water at a very high pressure is supplied. Okay, then on this side we have abrasive port, you can see abrasive port, through which abrasive particles are supplied inside here. So these abrasive particles may be alumina, that is Al2O3, or silicon carbide, SiC, or some other abrasive particles also you can use in this process. Okay, then there is a orifice is there. There is a orifice through which water jet is coming. This is the orifice. Okay, here I am showing. This is the water jet here. Sorry, this is the orifice through which this water will come inside. Okay, and here the velocity of this water jet, it is a very high. Okay, that velocity of the water jet can be as high as 800 to 900 meter per second. Again, it depends upon what pressure is used. Okay, so you have the mixing tube, this is a mixing tube or mixing chamber over here, and in this tube you can see clearly that abrasive jet is mixed with your water. Abrasive jet is mixed with the your water jet, and both from this from this both you will get the abrasive water jet. Okay, after mixing of abrasive jet and water jet, you will get abrasive water jet. Now while coming out of this from this mixing tube, okay, while coming out abrasive water jet from this mixing tube, we have here abrasive water jet. Okay, we have abrasive water jet. Okay, and velocity of this abrasive water jet is very high. Okay, with such a very high velocity, when it hit the workpiece, when it hit the workpiece over there. Okay, for example, suppose here you have the your workpiece here. Okay, for example, this is your workpiece, and when your abrasive water jet having high velocity, when it would hit this workpiece, then kinetic energy of the abrasive particles is only responsible for a removal of the material from the your workpiece. I once again repeat, kinetic energy of abrasive particle is responsible for a removal of material from the your workpiece. We can calculate that kinetic energy of individual particle, okay, by the formula, as we know that the general formula 1/2 m square, okay, where m will be the your uh, mass of that particle, and v will be the velocity with which it is hitting the your workpiece. Okay, with which the it is hitting the workpiece. Okay, and when it that abrasive water jet hits the your workpiece, it is not necessary all the times that is hitting at a normal or at a 90-degree angle to the your workpiece. Okay, as you can see on the in some cases also abrasive particles is hitting the workpiece, and that is moving other than the your 90-degree angle also. Okay, so it is not necessary all the time, it should hit at the no, that your 90-degree angle only. Okay, so this is a your working principle diagram. Okay, here I have explained the removal of the metal. Once again I repeat here, we are taking the water from this tube, so that water will have the high pressure as well as the high velocity. Then the water will come from this orifice to your mixing chamber, and from another side, from one port, abrasive particles will come inside this mixing chamber, and after mixing you will get the your abrasive water jet, okay, having the high velocity up to 900 meter per second. And from a mixing tube, your high velocity abrasive water jet will hit the your workpiece, and due to kinetic energy of your abrasive jet or abrasive particle, it will remove the material from the workpiece. Okay, due to the that erosion action. Okay, due to the erosion action. Got it? So here I have written mixing of water jet and the stream of abrasive takes place, and then a rapid rise in your abrasive velocity will occur in this your mixing chamber or mixing tube. Okay, and when impingement of abrasive that abrasive water jet, okay, it will happens on your workpiece material, then momentum transfer will occur, and due to that momentum it leads to the removal of material by erosion action, or you can call brittle fracture or the shear deformation, shear. Okay, and what are the speed of abrasive will be there, no, so that will be the near about 900 meter per second, as well as the pressure will be the near about 400 megapascal. Okay, so normally how the erosion action is there, no, so due to that cutting in upper part of curve will be there. Okay, that means the upper part of your workpiece, and the cutting in your lower part of curve is there, no, so that will be the due to the deformation. So that is the removal of the mechanism of metal removal. Okay, understood? Understood or not? Say yes or no in the chat box. Say yes or no, so that I can go for next slide. or if no, then I can once again repeat for. Have you understood or not? Only Sachin is saying yes. Other students, okay, please reply yes or no. Abhishek Shinde, Abhishek Shinde, Abhishek Shinde, are you getting my point or not? Pankaj, have you understood this point? Working principle of abrasive waterjet machining. So same principle is there as like your that waterjet machining and abrasive machining. Okay, nothing different from that. वैभव गाडगे, वरद लाट, वैभव, then Akash. Okay. So now I will give only 2 minutes. Now, see, uh, if you use the different textbook or reference book, you will get some different diagram. Okay, but it will not change the your working principle of the component. Okay, they may show in another way, maybe colorful or in the different way. Okay, but this is a simple diagram I have taken from the that advanced machining book. Okay, so you can draw this diagram also. Okay, if a question will ask the in the exam like the explain the working principle of abrasive water jet machine. At that time you can draw this schematic diagram. So now I will give 2 minutes minutes for you to draw this diagram. Okay, within 2 minutes you have to draw diagram, and after that we will go for the that your next point. Please draw the diagram. All of you, please draw the diagram. Okay. Otherwise, what happen? Just I am telling the everything. Okay, and you are sitting idle and you are just listening. So through that, learning will not happen properly. Okay. So for learning, sometimes you have to go for the practicing. Okay. So I am just asking to uh, draw the diagram. Okay, not no need to write other part because all the material I am going to put in group as well as in study material. Okay, all papers and the notes also. Don't worry. Please hurry up. Be fast. Okay, now let us move for next point. Now, before going to setup of the abrasive water jet machining process, here I have written some applications of this process. So, important application of this abrasive water jet machining or abrasive water jet cutting is that you can use this. You can use the robot, and also it can be used for dismantling of nuclear plant, power plant. Okay, with the help of the robot also. Okay, then uh, okay, again another application is that you can use for machining of different metals like non-metals. Okay, in that again ceramics, composite, and rocks also. Okay, cutting of or machining of. Again, you can use to machine metals. Okay, like copper, aluminum, or tungsten or lead, etc. Okay, again you can use for different operations, operation purpose. Okay, like drilling, cutting, deburring, etc. Okay, also with the help of this abrasive water jet cutting uh, machine process. Okay, you can cut any kind of metal. Okay, okay, having with a high edge quality. Then again, for this process is adaptable for remote control also. Again, recycling of the abrasive also it is possible in this process. As I have mentioned that dismantling of nuclear power plant with the help of robot. So that is the important application of this abrasive water jet cutting machine, because in nuclear power plant human beings are not permitted to go there. Okay, so because of the why they are not allowing to go human being, because uh, there is that radiation effects in there, no, so it is harmful to the human being. So uh, abrasive water jet cutting is useful for such a kind of application where you can control the cutting operation with the help of the robot at remote places. Okay, so remember this application. Okay, so I once again repeat this process you can use for machine for metals as well as non-metals. Okay, in that non-metal metal here I have written ceramics, composite rocks, etc. And metal you can machine that copper, aluminum, tungsten, then uh, other parts also. Okay, and the operations such as drilling, cutting, deburring purposes. So these are some applications. Okay, so this is about the part one. Now let us go for the next part about this topic, that is the setup or equipment used for this abrasive water jet machine. Okay, AWJ. So you can see the diagram. Now, with the help of this diagram, I will explain you the setup. Okay, now as we require high pressure water, okay, in this tube, so we have to take from the one reservoir. Now maybe so reservoir, for example, here you will have the reservoir. So from this reservoir you have to pump the water. So for that purpose we require the pump. Now again to remove the dust particle or other contaminant from that your water, we need water treatment plant. So this is water treatment plant. Okay, then from that water treatment plant you can pump the water. Then to increase the pressure of the your water, we need a hydraulic unit. It is called intensifier. Okay, and that accumulator also. So after the intensifier, we need to increase the pressure of the water. megapascal pressure will be there. So after that you will get the your high pressure water here, okay, and that high pressure water will come inside this tube, okay, and this is total your mixing chamber. Okay, now in the another from another port you will get the your abrasive, you will get your abrasive, okay. So this is the abrasive feeder. From this you will get the abrasive particles. Okay, and from this purified water will come. Okay, so after coming the water and this abrasive particle, they will get mixed with each other here. So after mixing, you will get abrasive water jet. Okay, and through this your mixture tube, it will heat or it will impinge uh, on your workpiece here. Okay, this is your workpiece. Okay, so that tube we can call it as nozzle here. Nozzle is there. So through this nozzle, abrasive water jet with high velocity, it will comes out from this nozzle tip, and it will strike or it will hit the your workpiece. Okay, so here I have written your nozzle is there, then abrasive water jet is there, and your workpiece is there. Okay, so due to kinetic energy of here due to kinetic energy of abrasive particle, the erosion or the brittle fracture will happen, and due to that erosion, material will remove. Okay, now whatever the jet is there, so after striking to this workpiece or after machining, if we want to reduce the that velocity of the average jet, okay, in before going to the drainage, so we require one unit or one component. It is called the catcher. This is a catcher. Okay, that we will discuss during the equipments. Okay, that time of at the time of that equipment I am going to take. So this is the working principle or equipment, how the setup is required. Now after this one by one unit we are going to cover that one every elements we are going to discuss. Okay, okay. Now before going to the all the elements, so I request all of you, please draw this diagram. Okay, so please draw this diagram. This is a equipment used or the setup or the system of your abrasive water jet cutting or abrasive water jet machining process. Okay, so please draw this diagram. Then we are going for this point, one by one. Here also we have to maintain that nozzle tip distance or standoff distance here. So you can see here nozzle is here and your water jet is here. Sorry, workpiece is here. So here there is a nozzle tip distance. Okay, it will affect on your material movement. So please draw the diagram immediately. What are the components we have studied in the your abrasive jet machining and water jet machining? Same components are there. Okay, in case of the water jet machining, there were that reservoir and the pump, intensifier, accumulator, okay, and the control valve. Okay, so same elements are also here. Also in abrasive jet machining, there were the abrasive supply hooper was there or abrasive feeder. The same is there. and the mixing chamber is required to mix that your water jet and the abrasive, so that you will get the high velocity abrasive water jet. Okay, and to get that high velocity, we need a nozzle. Okay, that we are going to see here also. You can see the one is the your pumping system is there. Then we have abrasive feeder. Then we have the abrasive jet nozzle and the catcher that we are going to see. So please draw this diagram. I will give you 2 minutes. Huh? Please draw this diagram. And the reference of this diagram I have written here. You can see here. You will get the link of the that diagram. Now, as I have already informed or told that the short videos of each and every points of our subject, that short videos which is prepared by me, all the videos are available on YouTube. Okay, so if you want to see that within 1 minute, I will just give the that within 1 minute. Okay, now you can see at YouTube, uh, if you just type hash LLGT, okay, hash LLAGT, hash LLAGT, okay, let's learn and grow together. And if you click anywhere, so you will get the my YouTube channel. Let's learn and grow together. Okay, so this is platform. Here, if you go in the playlist, then you will get the separate course. Okay, here I can show my course also. Huh. You can see non-conventional machining, non-conventional machining here. Just click here, you will get the all the lecture. You can see start from the uh, our that free course, that first lecture. Okay, which you'll give information about the which is the syllabus, who is your instructor, and all these things. Okay, one by one, all the lectures you will get here. You can see that introduction video is there. Sorry, first. For example, here if you want to see the our that this point abrasive jet machine, abrasive water jet machine. One I will just show you that also. Overview of abrasive. You can see here. Okay, so this is the video. Today, what I have taught you, know. So same things you can see here in this video. Actually, now the computer on which I am taking lecture, through which I am taking lecture, so it don't have that voice the other uh, that problem is there with the voice. Okay, so actually, sir, if you can see the same PPT will be there, and the okay, and behind this PPT, my voice is there. Okay, So you can visit um, this non-conventional course at Let's Learn and Grow Together YouTube channel, and you can have the all the videos. Okay, whatever I am teaching within 1 hour, so same things I have covered within the 15 minutes. Okay, so easily you will get the that concept or the topic within less time. Okay, you can anytime, anywhere you can watch this. Okay, this is for just your kind information. Okay, here all videos are here. Okay, I think near about 50 lectures, that short videos I have prepared. Okay, or more than that, maybe that. Okay, okay. Now in the lecture today, we have the another lecture. So that time we'll see the another remaining points about the average water jet busting. So quickly we'll take the attendance, and then we'll close our today's lecture. So I request all of you, please write your roll number in the chat box so that I can write from the chat box. All of you, please write your roll number once only. Okay. No need to write 2 or 3 times. And after writing your roll number, you can leave this meeting, no problem for me. Okay. Shubham Kakade, write your roll number. Just a BA your written. Not understanding your 30. Okay. Okay. So thank you very much. You can leave this meeting.